Hello, welcome back to Intuit Mathematics. In this video, I'm going to explain the concept of some basics of geometry. I will start with some historical background of how some notations, geometrical notations such as sine theta and cos theta were developed. And to lay the foundation, I will explain some terms that were used at the beginning before the adaptation of the notation sine theta, cos theta. So I will explain chord, which was very useful at the time, sinus, which is today sine, and 60, or the base 66 number system that was used in the ancient days. And to begin with, just like how we have base 10 today, base 10, that's why we're using base 10 in our number system. So that's when we count from 0 up to 9. Then after 9, you start with 1, 0, and that order. So that is base 10. The ancient mathematicians, they were using base 60. And this also informed the reason why we have 60 seconds as 1 minute, 60 minutes as 1 hour. And this somehow aligned with how they understood the movement of the earth, and also because it was discovered that the complete rotation of the earth, it's 360, so they use that to form that a complete circle is 360 degrees, and which is also dividing 360 with 60 was easy for them, and so that was the number system they were using before modern day that we now use base 10 and then binary for other purposes. And to relate this to our daily lives, or something that we can easily lay hands on, I would try to use the lid of this container, which I showed in my previous videos. So I'm going to take the properties of the lid which I recorded in the previous, which I measured in the previous video for this demonstration. So in the previous video, I measured the circumference of this to be 22 centimeters. The radius it's 3.5 centimeters. So I'm going to use the same thing to explain these things. So let's start with the term chord. Basically, chord, it's a straight line that connects 2 points on a circle. So in the ancient time, mathematicians were learning the positions of the galaxies, stars, and the rest. So, and because the earth movement was also in a circular form, they had to use these terms to be able to form or get a good way of representing the position of objects. So let's take it that this is the lid, which the circumference is 22 centimeters and the radius is 3.5. So we have, let's say we have a point here and another point here. So let's say point A and then point B. I'm going to name here A, and now label here B. And the chord is there, so let's draw a line connecting these 2 points. And oof, this is not a straight line. Let me get a straight line. Okay, now this is a straight line. This is a chord. So a chord is a straight line connecting 2 points on a circle, lying inside a circle. And there was this other, so let's take it that the length of this A and B, it's equal to um, let's take our line AB, it's the same length as our radius, 3.5. And what they discovered was that if you draw a line from the center to connect this chord at the point of intersection, it forms a right angle. Okay, so this divides line the chord into two, so we have what we call half chord. Now given this, I can easily draw a triangle from here. this makes a right angle. That's 98 degrees. And let's name here to be our center. So let me use the symbol C. And we can name here M as our midpoint. Right. Now let's look at how, if we want to find the angular position of these 2 points. So let's take it that we have B and A. We want to find the angular position. So let's take it that we want the angle between these 2 points. And this is where the concept of the sinus and so sinus is a Greek word that means half-fold. There is a historical background to how it came about, and there was kind of a translational artifact, but that I will not go into those details. I just want to explain the intuitive meaning of it, and I will not want to bother you with the literature. But there are two important things I want to explain here. One, it was further discovered that when the chord distance, so that's a line between, so when the chord length, it's equal to the radius of the circle, the angle between those 2 points is 60 degrees. And this is very important. And they made this relationship of what they call half chord ratio, and that is what today we term as sine theta. So in this case, our chord is AB, half of the chord is MB or MA. We can use any of them. Let's use MAC. Now we have a triangle MAC, and if we want to find this angle, we are not going to use any calculator. We will use a symbol sine, but we will find what it is. And the second concept, or the second important thing I want to explain is, so now we want to know the position of point A with respect to the radius, the center. So we want to know the vertical movement of A from this radius, the center point. So we can, to do this, we can use a ratio of the distance from the center to point A to the radius, and that is what today we have as sine. So when you put sine theta in your calculator and it gives you an answer, it's just using this relationship. So we have, that's what we call half chord ratio. Let's look at it. From A and B is 3.5, so half of this would be 1.725, and the half chord ratio is the ratio of the ratio of the half chord to the radius, and our radius is 3.5. So we are going to have half of 3.5 divided by 3.5, and that is going to, so we have this 1/2 multiplied by 3.5, all over 3.5. This would give us 1. The ratio, the half chord ratio of our lead, given these two positions, would is 0.5, and what that means is that point A is half of the radius length above the horizon. So this line is our horizon. Let me extend it for it to be clear. Okay, let's this is our horizon, our horizontal line, and that also explains the physical meaning of sine, and that is, sine describes the vertical position of a point or an object in relation to the horizon. It tells you the up and down movement or position of the object. Now in our case, let's see how can we get, with this 0.5, how do we get the angle if we want to get the angle of this. This is half of our radius. Earlier I mentioned that there is circle theory which says that when the length of a chord is equal to the radius of the circle, then the angle between the 2 points is 60 degrees. And with the same principle, if 3.5 is 60 degrees, then half of 3.5 would give us 30 degrees. And it means that this angle here is 30 degrees. And this, if you have your calculator and you point sine 30 degrees, you should get 0.5, and that is what we've shown here. It means that when you have two points that are the distance between them is the same as the length of the radius of a circle, the angles that those 2 points form, if you are taking from the center in a circle, you would get 60 degrees, and half of that will give you 30. And if you are looking at the position, also you can say that the point, in this case let's say point A, is about half of the length of the radius above the horizon. So that is the physical meaning, and that brings to the point of what does sine mean, or why do we even need to do that to learn these things. To put it in plain language or simply, sine describes the vertical position of an object with relationship to the horizon. That is why when let's have here as our 0 degrees and here as our 180 degrees, this is anti-clockwise movement anyway. Any angle in the first hemisphere, that is the top part of this circle, any angle here, if you take the sine of any angle here, you would get a positive answer. And it will be positive because all the points here are above this horizon. That is the meaning. And on the other side, any angle here from any angle that is greater than 180 degrees, when you take the sine, you would get a negative answer. And that also tells you the position of that point. It's telling you that that position is below the horizon. That is the intuitive meaning of sine. In advanced math, when, for instance, or apply math, if you are using taking movement of objects, pendulums, or a radio wave signal, these things would apply. So knowing the angle and then the sine will tell you the position or the phase of that wave. So if you are using a sine wave, in a future video I will explain the concept of cos theta or cos. But before that, just to give a hint, cos, the full meaning is complementary sine. So it's kind of like opposite to sine. And what the physical meaning of cos is also the left to right movement or position of objects. If sine is up and down or vertical, cos shows or tells you the left to right or the horizontal position of object. Now let me explain how sine 90 degrees will give you 1. Let's to get the angle between the point and our horizon to be 90 degrees, which means the central angle, the total angle between the 2 points should be 180 degrees. So that should be a straight line, because we are taking half of the chord, so half chord, that should be half of the angle. In that case, I will redraw the points. Maybe we have this. Okay, let me have here this one as B, and then we will have our next point to be B prime. I'll label here B prime, and maintain. Okay, now we have A and B, and we have A prime and B prime. These are our new positions. Now the total here, this angle should be 180 degrees, and half of it, this is our, now this is our chord. A prime and B prime is our chord, and this line dividing it will give us, if we are dividing it, we have this as our horizon. Let me use a different color. Now the angle between the horizon and then this point A prime will be 90 degrees. And the distance or the length of we still have our C, which is, yeah, from CA is the same as our midpoint as well. The length of this now is from the center to the point. That's the same as the radius. Now our half chord. Our chord is now the diameter, and half of it is our radius. To use the same half chord ratio, then now we will have 3.5 over our radius, which is also the same as 3.5, and that will give us 1. and this shows how sine 90 degrees is 1. And again, this also points to another important thing. If you at this point a prime, there is no any horizontal component here. This is a full rotation on the vertical axis. So it means that at 90 degrees you will get the point it's at the top of your circle or the peak, and there is no any horizontal component, and that is why cos 90 degrees is 0, because cosine describes or measures the horizontal, that is left to right movement or position of your object, and at 90 degrees is completely vertical. There is no any horizontal component there. As compared to A, you could still see that this is the horizontal part of it. So if you want to know so this has 2 points. It has the vertical that tells you how high it is above the horizon, and then also you can tell how far it is from the center of the circle. From the center to your right, you should be able to tell how far it is, and that is what cosine does. It tells you how far the point is from the center, and sine tells you how high it is above the horizon. At point A, to describe the position or locations, well, you would have to show both cosine and the sine. Just like in a graph you have x and y. Then at this point, also maybe you can use linear algebra to, at this point, if you were to use linear algebra, if you're going to use a linear graph, it will be 0, 1, because it's on there's nothing on the x-axis, it's completely on the y-axis. So this somehow explains how cos 90 is 0 and sine 90 is 1. To recap, we have learned that sine is the ratio of the distance between a point and the horizon to the radius of the circle. That is how the concept of the opposite over hypotenuse over hypotenuse. From here to here is the hypotenuse, and here the half chord is the opposite. And the physical meaning of sine is the up and down movement or the location of an object above the horizontal line. That's the, if you take a circle and you draw a diameter from your left to right across it, the sine of any object or a point is giving you information about the vertical position. On the other hand, cos or cosine gives you the position with respect to the horizontal, that is left to right position or left to right movement. For the cosine, we will treat that in the next video. And again, angles between 0 to 180, when you take the sine of them, you always get positive values because those points are above the horizon. And angles between 180 degrees to 360 degrees, you always get, when you take the sine of them, you always get negative because those points are below the horizon. Thank you, and I hope you enjoyed the video.